Okay, everybody, let's get started. We are doing a webinar today on Introduction to the Mysteries of Clickhouse Replication. My name is Robert Hodges, and I'll be doing the webinar. I'm also joined by a couple of my colleagues from Altinity, Alexander Zaitsev, our CTO, and Valerie Chachenko, who helps with marketing, and they will be assisting me today on the presentation. Before we dive in, I'd just like to introduce you to a couple of features of the webinar that we're using on Zoom. One is that if you have questions, you can go ahead and post them into the question and answer box. We've already got a couple good ones, which we'll answer over the course of the talk. A second thing that I should mention is that this webinar is being recorded, and we will post that recording as well as the slides afterwards. So you should automatically receive a link that will allow you to access the webinar as well as pull a copy of the PDF containing the slides. So you don't have to take frantic notes, and this also means that some of the examples in the slides will be available to you. You can copy paste them and use them for your own purposes. With that, I'd like to get going. I want to do a quick introduction to Altinity, and we'll also briefly introduce Clickhouse. One thing about the content of the webinar that I'd like to point out is that the subject that we're going to be dealing with today is a relatively complex one. This talk is designed to introduce you to replication as well as sharding and how it's implemented and used on Clickhouse. We won't be able to cover every detail. We should be able to answer your questions. Will be time at the end. But just bear in mind that there's more to this topic, and it's really not possible to fit everything into a single hour. We will be doing a poll, by the way, at the end, just to let you give some feedback on the talk. We like doing these webinars. This is part of an ongoing series to give presentations that cover big chunks of operating Clickhouse, and we'd love to get your feedback on how to make this webinar better, as well as to choose new topics to cover. So with that, let me briefly introduce Altinity. We're the premier provider of software and services for Clickhouse. Our customers include enterprises worldwide, in the United States, in Europe, in Asia. We don't have anybody in Africa quite yet, but we're working on it. We provide enterprise support for Clickhouse as well as the ecosystem projects, for example, the Python things like the Grafana driver as well as Python. That's 24/7 support that enables people to run line of business systems. We also do quite a bit of Clickhouse feature development. I've listed a few here, things like geohashing codecs. We're working on tiered storage. We have a feature for log cleansing for security. These are all things that are current work or things that we recently completed. We also write software to help you manage and operate your clusters on or your Clickhouse installations. Specifically Kubernetes. We are the authors of the Clickhouse Kubernetes operator, which is a very, very useful tool. We'll talk briefly about it at the end of this talk. We also have a cluster manager coming out, as well as other tools and utilities. And finally, we do POCs and training, everything that's necessary to help you do evaluations and get started. We are, I should mention, the main US and European sponsor of the Clickhouse community. We work very closely with Yandex in building a worldwide Clickhouse community. Let me talk very briefly about our star software today. That's Clickhouse. So just one second here. Actually, I'd like to, there we go. I wanted to make sure the menu bar was not visible. So we won't be talking very much about the general features of Clickhouse, but if you're new to it, here's a very, very brief overview. So Clickhouse is a SQL data warehouse. It stores the data in columns. It's quite portable. It runs on Linux systems, but anything from bare metal operating systems all the way up to cloud. It also runs very well on containers. Similar to other column stores, it's very good at parallelizing operations, so it's MPP enabled. We can easily spread processing across many, many nodes. That's something we'll be talking about implicitly today. It also uses what's called vectorized execution to ensure that we execute queries very efficiently. So as we look at columns, the data are stored as arrays. Those arrays are compressed. We basically break them up into pieces when we're doing queries, farm them out to all the cores that are available on the machine, and process them as efficiently as possible. Clickhouse scales to many petabytes. You typically begin using it when you get into the range of hundreds of millions of rows, the point where things like MySQL, Postgres, and other traditional relational databases break down, and it scales all the way up to tens of petabytes. It is open source. That's a big selling point, licensed under Apache 2.0, and it's extremely fast. We've covered all these topics on other webinars as well as public presentations, so if you want more information on any of these topics, go ahead, check out our website. There's lots of materials there, and there's lots of information on the internet. So with that, I'd like to go ahead and just jump into the description of replication concepts. So let's have a quick look and just talk about replication in general. This is a technology that's fundamental to any system that manages distributed data. And what we mean by replication is that we have a copy of data in one place and we're going to make copies of it in other locations. Traditionally, replication has helped solve three major kinds of problems. The first is high availability. So if you have a couple of copies of data and one of them catches fire, you can just switch all your services to talk to the other copy. So that's one of the first and primary uses of high availability, and when we're talking about replication on Clickhouse, it's no exception. Another way that you can use replicas is load scaling. So if you have many clients which are attempting to run heavy queries, being able to break the data up into identical copies in different locations means that you can simply spread the query load over many machines and get better performance. And then there's a final area where replication is very useful, and that's in migration and upgrade. So, for example, we may have a replica which is running on one version of Clickhouse. We want to upgrade it to another one. Now, that's going to require a brief outage, but if we have replicated copies, we can update the replicas one at a time, and the users will not notice that anything's happening. So these are major uses for replication, and Clickhouse supports all of them. So as we look at replication in more detail, we also want to talk about the concept of sharding. And replication and sharding are two different things in Clickhouse, but they're very, very closely related. So this slide shows a simple example that illustrates the differences. So when we talk about data being sharded, we mean that data is broken up into disjoint sets. That's the first picture. So for example, we might have a big a cluster which contains, say, a lot of log data. It's too much to fit on machines, so we split it 4 ways and put it on 4 machines, and that way we have enough capacity for it. So sharding is one of the fundamental things that helps us to scale to large volumes of data. Replication means that we're making copies of it. So you can also define a topology where you just have one copy of the data and you replicate it to all your machines. And that's the middle picture. And then the most common way to use this is actually to combine sharding and replication. So we want the sharding so that we can scale the data distributed across many machines and therefore deal with a much larger data set. But we also want the replication because that gives us the ability to do HA, scale load on particular shards, as well as do things like migrations. So in each case, Clickhouse has a way of handling this, and it's using something called a cluster. So Clickhouse is actually quite happy to shard and replicate the data in multiple ways simultaneously, and we'll see examples of that as we go through this talk, and we'll also talk about this notion of clusters quite a bit. Just a little bit about the implementation. So the way that Clickhouse works or is implemented is it's actually an extension to MergeTree. So MergeTree is the basic table engine for Clickhouse. It is what you're going to use for most of your large-scale data processing when the data is stored in Clickhouse itself. Merge tree has many variants. So, for example, summing and aggregating merge tree are commonly used in materialized views. There are other engines here, and in each case, there's an extension to the engine which includes replication. So what this means is that when we talk about replicated data, it's going to be using merge tree and have the usual merge tree behavior, whichever engine you've selected, but in addition, it's also going to be replicated. It follows from this that replication in Clickhouse works on the basis of tables. So if you're familiar with replication in Postgres, in MySQL, they use a log. And so, for example, in Postgres, when you make a change, it goes into the database log, and then Postgres has the ability to replicate that log to another location. Every single thing that you change in the database goes into that log and gets replicated. So it's kind of an all or nothing thing when you're using the basic replication. MySQL takes a similar approach, uses a log, although you can actually tune it to leave things, put things in or leave them out. Clickhouse is purely on the basis of tables. So this picture shows the basic operation. When you make a table be replicated, you use one of the replicated engines, and then what happens is when you insert things, for example, on node 1, if you insert something into table events, it will get replicated over to other copies or replicas, as we say. And this replication is asynchronous. You'll normally insert, although there's ways you can change it, but you'll normally insert, the part will get put in, your application will go off and do something else, and meanwhile it'll replicate to the other copies. There's other kinds of replication that go on because we also have background merges with, as I think most of you know, with merge tree, what happens is you insert the parts, and Clickhouse basically puts them in parts that basically match the size of the data that you're loading, and those may not be necessarily be the optimal size for the fastest reads. So in the background, Clickhouse will be merging the tables, and that is also coordinated as part of the replication. So what will happen is we don't actually need to move the merged parts, but what happens is that the replication mechanism will select one of the tables to be in charge, basically to be the leader. It will determine how the merge should happen, and then it tells the other copies. So this is an example of a coordinated operation. Each of the tables then steps through it together. And then finally, in addition to background merges, there's DDL and truncate statements. So these are operations which are also coordinated. So if you issue a DDL statement on one table that is replicated, it will then be replicated out or repeated on all the other tables. So these are three different ways that the replication works, and the effect is that once you set this up, pretty much anything you do to the table, including inserting data as well as changing it, is going to get replicated to the other copies. Replication in distributed systems, or this kind of coordination, requires some sort of distributed store which is consistent and able to store the state of all the replicas. And Clickhouse uses Zookeeper for this purpose. So we will talk about Zookeeper setup a little bit later in this talk, but I just want to highlight some of the kinds of information that's stored inside a Zookeeper node. This includes things like all the DDL that needs the specific DDL requests that need to be replicated and applied to different replicas. There are also descriptions of the tables. We track the leader for merges. When we're doing operations on a specific table, somebody has to be in charge and tell the other replicas what to do. We have a log of actions. One of the biggest things that Clickhouse stores in terms of volume in Zookeeper is information relating to parts. So all of the parts are listed there, and this can actually create quite large volumes of data. And then there's additional related informations like block checksums, which are used to handle deduplication. So Zookeeper stores a great deal of information, and it is a critical part of the replication system. When you set up Clickhouse replication, Zookeeper is always in the picture, and what you get is something that looks kind of like this slide where you have your Clickhouse nodes, which are storing the data, and then you'll typically have some number of Zookeeper nodes in production settings, normally 3 or 5, and they are responsible for maintaining the distributed state that helps us coordinate the replication. So this is going to be your basic setup as you implement this in production. And just a few extra things. There's specific port numbers shown in this picture. 9000 is the default port number for when you're using the native client format, sometimes called the native TCP/IP format. That's where the client's attached. 9009 is a port number that's used to share information between replicated tables. That's communication between the Clickhouse instances. And then Zookeeper, by convention, talks on port 2181. So if you're operating in firewalled environments, you'll need to, or sort of areas with high network security like microsegmentation, you'll need to ensure these ports are available. So that's kind of an overview of the concepts. What I'd like to do is jump in and actually talk about how we do the base setup for replication. But before I do that, I'd like to just do a short demo that shows what replication is really like in out in the wild. So let me go ahead. Let me go ahead and escape out of this, and let's pull up. We have a couple of windows here, and what I've done here is I'm running a setup where I have 4 replicas, actually 2 shards with 2 replicas each, so sort of like that sharded and replicated scheme that I showed you before. And I've got a couple of tables out in each of my on each of my nodes. My current database is test, and if I do show tables, you'll see that I have events and events local. So let's look at each of these in turn. So we'll do show create table on events local. This is the replica. So it's the replica table. And when we show the create table, what we see is that it has the normal table definition, but it's using this table engine called replicated merge tree. And that includes some extra parameters like this long path as well as the name of the replica. We'll talk about how those get filled in. It has a partition key. It has order by index granularity, usual stuff. So this is actually the replicated table. And what this means is this is going to have a copy of the data that's being stored in that particular shard. And then the next thing is we have a distributed table. And a distributed table is kind of like a load balancer, which can handle both inserts as well as selects, and it will pick suitable replicas to send to replicate or to send the queries to. And what this does is we call it the create table shows the same table definition. The engine is distributed, and then we have some information that helps us locate the underlying tables. And then finally, there's a function here at the end, random, which just generates a random number. And this is called this is a sharding function, and it basically tells how are we going to decide where to send rows of data as they're loaded. We have 2 shards. We need to decide where each row goes. In this case, we just run random and basically roll the dice. So that's our tables. They're pretty simple. Let's just do some pretty quick queries here. So we'll do a select star from events, the distributed table, and see if there's anything out there, and we see there's nothing. Let's go ahead and insert some data. So we're going to go ahead and insert some data in. So we insert this data, and let's go ahead and insert a little bit more. And what I'm doing is inserting through the distributed table, and at this point, if I go ahead and select off the distributed data, I should see 2 rows. So let's go see if that works. Here it is. Okay. We see both of these. They're coming back in different groups because they're different parts. If I go ahead and see what's actually in my local table, in my little replica, I only see 1. And that's because this data has actually been distributed across different replicas or across different shards. So in the bottom window, I've got a ClickHouse client pointing to one of my other shards, And if I do that same query here, so select star from events, first of all, I'll see all the global data because the distributed data points to all shards. And then if I select my local table, I'll only see the local data. One of the things that's kind of interesting and that I often use when I'm just setting things up is it's kind of useful to figure out what is available in which location. Here's a simple way to do that using the remote table function. So this is a kind of nice function which shows us that allows us to see basically to see which host we're running on, and then all the data that's available on that host. And what this comes back is it shows that my host names, it shows my data and which hosts they're on, so I can check to make sure my sharding and replication is working fine. So this is an example of basic data. We can see that it's spread out across different shards. We've got different replicas. There's a couple of system tables that I'd just like to show you briefly. So we'll just look, there's quite a bit more information available in the system tables, but let's just look at system.clusters. This basically gives us a list of all the layouts for sharding. These are called clusters. These are then shown, and we also get a definition of which host we got belongs to which element in each of these clusters. The one that we're using for this particular table is a cluster called sharded and replicated. We'll see a little bit more of that in a minute. And then another thing we can see is, so this gives us all our clustering layouts. The second thing is we can also see which tables are currently replicated. And we just have one. This output is a little bit messy, but this allows us to see the exact table that we're replicating. And you can see these kind of long paths. These actually correspond to information that's being stored in Zookeeper. What I'm doing right now is I'm actually in Zookeeper, and I'm going to do a quick ls command to dump all the data that Zookeeper is storing about these tables. And as you can see, there's actually a fair amount of information here. And if we back up, this is we see all our old DDL queries, and as we eventually get past that, that's quite a bit. So we get back to the actual information about these individual tables that we're replicating. All of this information is in Zookeeper. You can go in and look at it. But as you'll see later on in the talk, it's very important to look at it but not touch it because you can mess up replication. So that's the demo. Let's go ahead and get back to the presentation. So let's go ahead and bring this back up. And if you have questions about anything you've seen here, feel free to bring them up. We'll now look at some of the details. Okay, great. Looks like we're getting some questions here. Actually, one that I'll take right now is, do you create distributed tables on every host? In this particular example, I did, but you don't have to do that. In fact, there are many cases where you'll have some, depending on how large your cluster is, it's quite common to have some tables, or excuse me, some hosts handle distributed tables and others just have local data. So it's up to you. You can really use any pattern you want. Clickhouse doesn't care. And in fact, that's a common theme in everything we look at today. Clickhouse is very flexible. You can organize the clusters almost any way you want. You can also have distributed tables running practically anywhere. So it's very flexible. Okay, let's briefly review the steps that got us that cluster. So when you're setting up replication, the obvious thing that you need to do is go ahead and install Clickhouse. 1911.3 is a good version to use. Here's I typically work on Ubuntu, so I'm using the Debian packages. You're also going to need to install Zookeeper on at least one additional node. You can do that through packages, or you can install it directly through from the site, and we'll talk about the trade-offs for that in a minute. So there are some setup files or configuration files that you're going to need to set up to make everything work. The first thing is you need to define your remote servers. These are your cluster patterns. So what we see right here is the sharded and replicated is a cluster, and it defines a layout of data, and you can see there's a shard here. It has two hosts mentioned. That means that when we're running queries or loading data, these will be considered replicas that we can go to get the data. There's a setting here called internal replication, which you'll commonly see. Normally that's going to be set to true. What that means is to use the Zookeeper-based replication. If it's set to false, what will happen is a distributed table will actually just replicate your inserts to different replicas. It'll just run them, execute them directly, but it doesn't have much error checking. So you can have many of these, so sharded and replicated, we just show one here, but you could also have other ones called sharded, one called replicated, and these can be any layout that you want to allow you to access the servers. It's up to you, and then your distributed table will know which one it's supposed to use when it's directing queries. So that's an important thing to set up. The next thing that you want to set up is something called macros.xml. And these names, by the way, are conventional. You can do this any way you want, but this is the pattern that we use, and it helps keep things straight. So macros are just, as the name sounds, are just some variables that these are going to change by server. And what this does is it's just telling me that, hey, on the server where this file is running, my default cluster is sharded and replicated. I'm on shard 1 and I am replica 1. So this means that I can now put these as dropouts in queries, as you'll see in a second, and the queries will execute across the entire cluster and get the right values. A final thing you need to do is tell where Zookeeper lives. So you'll have the Zookeeper, we put that in zookeeper.xml, you give the host names, and then there is one path that you give here, which we actually saw briefly a second ago. This is the task queue for distributed DDL. There's basically one for, typically one per server. This file is important because if you make changes to it, you'll need to restart Clickhouse. It does not recognize them, but changes to macros as well as the cluster layouts, you can just change them and Clickhouse picks them up automatically. So when you're doing your setup, what we're going to do is go ahead in this case, because we've just installed and also because we're configuring Zookeeper, we're going to do a restart. That'll get the servers up and running. And then what we can do is on a single server, we can just create the tables. And these are commands that show how to do this. It uses we create the replicated table events local. We use this on cluster phrase, and that says do it on a specific cluster. And what's going to happen is that cluster name is actually going to get filled in from the macros. And we're going to do the same thing with the distributed table. We're going to do on cluster, give it a distributed cluster name, and then tell it which table to look at. So that was what we did to set this stuff up. And then finally, we can start adding data. And as I showed in the example, I was inserting into events. So you can insert via the distributed table, or you can insert directly into the replicated table. So great. So that's the basic setup. And I do see one question here, which I think we can just answer right now. I hope that in the distributed table, I've explained the difference between the internal replication equals false. I think in general, most people use internal replication equals true because the built-in replication is just way more robust. If you set it to false, what's going to happen is we're going to send the inserts to all replicas. But if one of the inserts fails and another one succeeds, there's no error checking and there's no correction. The internal replication will solve that. So unless you're sort of blasting out data and don't really care, then you're going to want to use the internal replication with Zookeeper. Okay, so I'm not going to talk about selects here because we've already looked at them. What we're now going to do is jump into some of the standard lifecycle procedures and hopefully go over these fairly quickly because there's questions piling up here and I'd like to have lots of time to handle them. So just starting out, as you're thinking about managing replication and using it in production environments, you want to think about how different SQL commands are treated by this internal replication mechanism. So this table that we're looking at shows you whether commands are replicated or not, and also whether they support this on cluster phrase. So for example, create table and drop table, as well as create and drop databases, are not replicated. And these actually set up the table locally, and if you say on cluster, they will be repeated across the entire cluster. And that allows you, for example, if you want to create a database across the entire cluster, you can just say create database test on cluster, sharded and replicated, and every single server will get that database created. That's actually how I set them up. Same thing with create table and drop table. The drop commands are really important because they not only remove the table, but they also remove all the information from Zookeeper. That's really critical because if you don't clean up Zookeeper and you recreate the table again, you can end up getting really confused because there's already information there. So it will have invalid replication state. Commands like select and insert, select is not replicated. The distributed table applies it across shards, so it basically does a federated query. Inserts are directed. Again, the data gets inserted in one shard, and then it gets replicated to the replicas. And then things like alter table, optimize table, truncate, these are all replicated, and they also support the on-cluster command. So we'll see examples of that as we go quickly through some of the major procedures. So a big one in replication is adding a new node. Let's say you're growing, you want to add a new shard. So what you're going to do is you're going to install a new Clickhouse server. You're going to create local tables on that new server, so use the create table command. And in that case, what happens is when you want to, just by creating the table and giving the right path name for it in Zookeeper, it's going to automatically, the table engine will automatically connect to Zookeeper, find out what data is out there, and replicate it automatically in and fill your table. It's totally easy. It may take a while if you have a lot of data, but it's very quick. And then once that cluster is ready to, or once that new node is ready to go, you can go ahead and update the cluster definitions of the other servers, and that will then enable traffic to come, for example, through distributed tables. You'll now get traffic coming onto that host. So this is essentially the procedure you would also go through if you lost a node and you had to recreate it. You basically bring one up, create the local tables, and then connect it back in. As far as the specific commands, it's fairly straightforward. As I say, you run the local SQL. You can go to the slides and copy this out. And then the other important step, of course, is you need to update the servers, and this needs to be done. Since you're adding a new server, in this case it's IP address 72, every server that's going to be using it in any way must have the same cluster definition so that it can find the server and access it. So similarly, if we want to remove a node from the cluster, if you want to do it peacefully, you basically are going to just reverse this procedure. So you'll remove the node from the other cluster configurations. That's going to stop traffic from coming to it. And then once the traffic is stopped, you can do things like check for merges. We can show an example, but basically once the node is quiesced, you just go ahead and typically delete the replicated tables. That's going to remove the Zookeeper data. And then if you're living up in Amazon or you want to repurpose the node and if it's racked, you can then just discard it, stop Clickhouse, and throw the node away. The commands you use to the drop table command is kind of obvious. You only have to drop the replicated tables. Another handy command is the drop database, as I mentioned. That will remove all tables, but it'll also clean up all Zookeeper paths for that database. So these are both pretty handy. We strongly recommend against cleaning up Zookeeper by hand. The problem is that if you do this, two things could happen. One, you could make a mistake because you just get fat fingers and destroy something. But the second problem is that Zookeeper may be in a state that you don't expect, and by removing the wrong thing at the wrong time, you can corrupt everything. So really important to avoid if at all possible. Changing table schema is really straightforward. You can just do alter tables. A typical way to do it is alter table and then use the on cluster phrase, give the cluster name. One little gotcha is that when you're doing, you'll have to use the right sort of cluster. So when you're changing a replicated table, you use the sharded and replicated cluster. When you're changing a table that is distributed, you have to use a sharded cluster. In other words, it's non-replicated. This is one little trick that you may run into. Managing in data and partitions, again, truncate table. We just showed our alter table. Like alter table on cluster can enable you to drop a partition across the entire cluster. So that's fairly straightforward. You can also detach partitions, things like that. And truncate works very nicely across the entire cluster. I use that constantly to clean these tables out. So just do it on cluster. And again, if you don't, these are replicated commands. If you don't include on cluster, it's only going to clear the replicas that you're looking at. And then resyncing, if one simple way to resync is if something gets screwed up and broken, just drop it and recreate it. That'll replicate the data back in. So there are sometimes other ways to fix things, but this is a very simple way of cleaning up data and getting it back again. And there are times when, for various reasons, like if your Zookeeper state did get messed up, this would be a way to fix it quickly. And then one final procedure, which is important to understand because it'll happen when you're working with existing systems, is how to add an unreplicated table to replication. So this is a complicated procedure, and yes, we are looking at this slide, and we all think that it could be automated. But for now, this is the set of steps. We're working on automation, but we don't have anything to announce yet. So basically what you're going to do is you're going to create a local table, which is replicated. So you'll do this on one node. You'll create the replicated table. You're then going to stop any traffic coming to the source, what we call the source table. That's your original. And then you're going to detach it. Then you're going to move all the parts across to the replica table, attach them using an alter table attach, and then you'll reattach the source and drop it, and you'll rename the replica so that it has the same name and basically replaces it. Obviously, this is going to have an impact on your applications, so it's fairly fast because moving, assuming you're just moving you're typically moving within a single file system, so it's a fairly fast operation, definitely something you want to automate. And then finally, once you have this table, the one replica set up, you can go ahead and create replica tables on the other nodes, and just as we saw on previous slides, they'll automatically fetch the data over. So this is the basic procedure. The actual steps are shown in the slides, and you can grab them later. One thing I would highlight is that when you're doing this procedure and replication in general, the path you use in Zookeeper, it's important to set that right because you can't change it. It's very, very hard to change it later. In fact, I think it's basically impossible. So you don't want to have to do that. Beyond that, there's basic steps shown here that generate some of the commands to transfer parts and reattach them, and then you finally bring them over, drop the old table, and then create your replicas. So it's a fairly straightforward procedure. I'd strongly recommend testing it carefully before you do it in the wild. Okay, let's talk briefly about Zookeeper very quickly. We'll mention Zookeeper configuration, steps to get it up. You can use, and this is a question that does come up. You must use at least Zookeeper 3.4.9. If you're using recent Ubuntu installations, the packages will install 3.4.10. That works. You can also install Zookeeper directly, in which case you get version 3.5. As far as I know, there is not a huge difference between these. And Alexander, if you want to comment on these, I know from a management perspective, 3.5 is better. It's got a better version of ZK CLI, but as far as actually the reliability of it for managing replication, we don't see a huge difference. Alexander, if you have different opinions on that, you can sing out. The one very, very important thing about setting up Zookeeper is there's a thing called auto purge, which removes snapshots. You must enable this, because what will happen is Zookeeper makes snapshots which can be used to recover the node, but they don't get cleaned up automatically. So if you don't enable this, eventually Zookeeper will stop, and that is bad because it means that your cluster may stop working. That brings us to a few quick points about how to keep Zookeeper happy. Install on separate servers. We recommend fast storage, SSD for the logs. In production, you always want to use 3 or 5 nodes, or even 7. It's an odd number of nodes, but not 1, and definitely not 2. So this is kind of like the holy hand grenade of Antioch. You want to have 3, typically. We mentioned auto purge. We don't recommend sharing Zookeeper with Kafka. The access patterns are different. We also really do not recommend cleaning up Zookeeper manually unless it's a dev environment and you're just blowing things away to restart a test. You can use snapshots for backups, but bear in mind that recovering both individual nodes as well as entire clusters is a manual process. So if your Zookeeper fails and completely falls flat, that is not going to be very easy to recover from. So what we recommend is that, among other things, you can keep observer nodes if you're a Zookeeper expert. This is a kind of node that doesn't vote, but could even be in another data center, and we'll see an example of that shortly. The Yandex Clickhouse docs have great tips on Zookeeper, so definitely check these out. So that's Zookeeper. Most people, once it's up and running, don't have a huge number of problems with it, although we do have a question about it, which we'll get to right at the end. So applications of replication and sharding, let me quickly pass through these so that we can get to questions. Distributed tables and select. So the basic idea, as I mentioned, is a distributed table is a kind of load balancer. So when we select from the events table, what it's going to do is it's going to use the cluster definition to pick replicas. So in the example we see here, we went and picked a replica because this definition has 2 shards and 2 replicas, we know we've got to pick 1 replica from each shard, so we pick the right events.local table for each one. What's cool about distributed tables, though, is they work in cases. The thing you get in large systems, especially, is replicas may be dead or slow. And so the distributed table understands the notion of latency. So, for example, if there's a setting that you can use to control whether you will send queries to replicas that are lagging behind. Normally what we'll do is skip those. And the other thing is if a replica is dead, in fact, it's simply not responsive, we won't send the queries there. So this is very, very handy. It both covers you for things where, for cases where things just die, but also for things like maintenance where you turn something off because you're, for example, migrating the node to better hardware. So that's distributed tables. One question that commonly comes up is it better to load through distributed or local tables? And there's trade-offs here. So this picture, let's get show it a little bit better. This picture shows the basic trade-offs. Clickhouse doesn't care. You can insert wherever you want. If you go through the the distributed table, Clickhouse is going to handle the sharding for you. It's automatically going to break up the data. It means your application doesn't have to know how it's split up, so you kind of encapsulate that knowledge. On the other hand, when you go to the distributed table, it's going to cache the parts locally because it's actually going to break them up using the sharding key or the sharding function, and then it's going to asynchronously insert them into the correct replicas. So you get this, sort of extra writes, async insert, and as a result, you get smaller parts being inserted because they're being broken up. If you go to the local events, the downside is your app has to know what the sharding pattern is. So it must understand that hey, you have to set up the application so they don't overload some nodes and not others, or some shards and not others. But it's faster, and you get larger parts. So it's actually quite. A lot of people do this, and particularly when you're operating at scale. For smaller installations, it doesn't really matter. But these are the basic trade-offs. How can replication help with migration and upgrade? Well, it's pretty simple. Because of if you're using distributed tables, you can basically shut down replicas anytime you want, or shut down their nodes. And so for a software grade, for example, you would shut down Clickhouse. You might upgrade it. I'm running version 8. I'd like to be on, or 19.8. I'd like to be on 19.11. Upgrade, restart, and then it joins and catches up everything it missed. More interesting, if you need to shut down, like if you want to migrate to more capable hardware or to a better class of VM, what you can do is similarly shut down. You can discard the node. For example, you can just, if you drop the tables, throw the node away if it's a VM, make a new node, put the table definitions back on, they'll replicate in, and then it can rejoin the cluster. So very simple procedures, and you can basically migrate without your customers seeing downtime. A final question we get in terms of topologies is how does multi-region replication work? Since a lot of people do run across multiple data centers, so the basic there's various ways to do it, but a common way to do it is to have, let's say you have two data centers, we'll call one primary, one secondary. So we're going to replicate, we're going to have an active zookeeper ensemble. That is to say that 3 zookeepers that are making decisions about replication, they're going to be in the primary data center, and we're also going to do all our inserts there. And the reason we do this is it means that we're going to be making the decisions, basically doing the data loading and making the decisions about distribution of data in one data center where the latencies are low and we're unlikely to have timeouts or partitions. And then what we do is in the secondary data center, we just do selects. We can keep zookeepers for backup purposes because maybe we're afraid we'll lose that data center, but we'll just keep them as observers. We don't actually use them for replication. And then what happens is if you lose the first data center, you can just go ahead and change your configuration files, both for Zookeeper to bring them up as active nodes, and also for the ClickHouses to point to them. So this is a pattern that people use. There are other ways to do it, but this is a common one. And it does bring up a question, and I think this is one thing I want to just sort of leave you with, is there's incredible flexibility in this. So when you're thinking about distributing data across data centers or creating subsets of data, you can define clusters. In other words, layouts that define sets of servers that include shards and replicas that let your applications refer to different subsets of tables or different subsets of data through distributed tables. So it's a very, very flexible way of doing this. And what we would do in that previous example is if we wanted to just go to DC1 cluster, we would do all our inserts using the DC1 cluster definition. We would do our selects on the other data center using DC2, and if we wanted for some reason to talk to everything, we would go through the global cluster definition. There's way more to to say here, but we're sort of running out of time, so I'm going to pass on. There are various ways that you can tune and diagnose these systems. I'll just mention there are system tables, super useful. This is one of the great features of Clickhouse, that the system tables are very, very accessible and easy to understand. There's a number of them that are relevant for replication. I showed a couple of them in the demo. There's also a bunch of tuning parameters, merge tree settings, as well as session settings. The queries here show how to get them from the system tables. Oh, actually, one of them is the query on the left has a typo. It should be settings, or merge tree settings, as opposed to settings. In addition, there are more parameters in the cluster definitions that allow you to set load balancing policy for distributed tables. So lots of good things there. And then finally, I like the remote function. I use it for checking data, but you can even use it your applications can use it to access replicas and shards flexibly, so you can even build your own sort of ways of accessing distributed data using this function. So that's it. So we had a set of mysteries here, and we have a bunch of solutions. So we covered sort of the overall role of replication, and I think one thing I hope you've seen in the talk is that Clickhouse is incredibly flexible. You can define many kinds of sharding and replication layouts. As long as you're willing to maintain them, Clickhouse is happy to implement them or to use them. The Clickhouse replication works on tables, so it's not like the whole database or the whole or a whole catalog or something. It is individual tables that are replicated. We replicate inserts as well as DDL. The distributed tables are like load balancers that can spread load across shards and also give your applications ways of finding sets of data that they need to access. And finally, Zookeeper is a critical part of this architecture. If a Zookeeper is healthy, your replication is likely to be healthy. So we recommend following the best practices for setting it up, and if you can avoid it, never make manual changes to Zookeeper data. That can be a recipe for disaster. And one final question is, you're probably looking at this, if you're new to it, you're thinking it's kind of complex. If you're, have a question, in fact, the question just popped up, this is very timely, is there any automation around adding hosts to a cluster? The answer is yes. Clickhouse Kubernetes operator. So one of the things that we're the authors of this, it allows you to run data warehouses in Clickhouse data warehouses in Kubernetes, and that's absolutely something that it just handles automatically. You basically say, hey, I want another shard, or I want more replicas, and it will just add them for you. And it will do the configuration automatically to set up the new nodes. It will also adjust the configuration files for all the other nodes. It's incredibly flexible and very, very useful. So if you have not tried it out but are Kubernetes, use Kubernetes, definitely check this out. It's really great. So with this, we are done with the talk. So what I'd like to do is turn over to questions. While we're doing that, I'd like to go ahead and I ask you to fill out a short poll. You can help us by, let me start this. I'm going to go ahead and launch it. So you'll see just some questions. If you don't mind filling those out, I'll just show them as they're coming in. We'd love to get a little bit of feedback on this talk because we'd like to make it better, and we also want to introduce other webinar series. So any feedback you can give. Let's see, so we have an open question here which is, first of all, how to reduce the amount of data that the Clickhouse sends to the Zookeeper when data is inserted into a replicated table. I've got 100 megabits per second on my Zookeeper network card. Alexander, do you have audio? Because that might be a good one to just answer directly.
Yes, thanks, Robert. I do have audio. For If you want to decrease amount of traffic with Zookeeper, you probably can consider some most recent Clickhouse versions that have handy settings for optimizing Zookeeper traffic. They are not enabled by default because if you enable them, you cannot downgrade, and this some most recent Clickhouse versions may have issues and so on and so on. But generally, there is very good setting that reduces amount of data that Clickhouse would store in Zookeeper, and this in turn reduces the traffic quite a lot. Another option to reduce amount of data stored in Zookeeper, just to reduce amount of parts. So, for example, if you have too many tables and you don't partition them properly, you have too many partitions, that may result in a lot of files in your file system. And that has negative effects on performance of Clickhouse itself, and also as a side effect, increases the amount of data you need to store in Zookeeper as well.
Great. I hope that answers the question. And then, Alexander, do you want to comment on the version of Zookeeper? Because I did mention in passing that we don't see a huge difference. Do you have preferences on that?
No, we don't have any preferences. Anything which is supported in Clickhouse, I think it requires at least 3.4.9 version. It works, and the particular version is more dependent on other software that you might be using with Zookeeper. Clickhouse doesn't use a lot of Zookeeper features.
Right, and if you do set up 3.5.5, I know on Ubuntu at least that's not in the package repos yet, or in the Debian package repos. So you'll need to set it up by hand, but it's really not very hard. It's very straightforward. Let's see. Here's one. If I have a table sharded in 2 nodes, what happens if I lost one of the nodes? Can this be restored from Zookeeper? Sounds like, Alexander, I think you may have answered that one.
Yes, I just did. So if you don't have replication, there is no way to restore your data. So replication is a way to be safe. And the data itself is not sitting in Zookeeper. Zookeeper only keeps a track of some Clickhouse metadata. The data is in Clickhouse data files. And the replication ensures that you have at least 2 copies of the data, and better to have 3 copies.
Right, and I think this brings up an important point. We get asked a lot, why doesn't Clickhouse have a backup utility? And the usual answer is that it has replication. So this is the standard, particularly for larger environments where the data volumes are so large it's just not practical to back them up. This is the standard way that you protect yourself from failures. So if you make a replica, it really is pretty easy to manage this. And then if you have problems, you can always go to the replica. And it does, as we showed in one of the slides, it does work cross-site. So it gives you kind of like it gives you also an option for cross-site DR. Let's see, other open questions. I hope we explained the distributed table. Actually, Alexander, do you have a case where you would use internal replication equals false? I can't think of a good one.
Yes, I can imagine such a case if, for example, you set up some remote replica for the different purpose. So you can insert data. For example, you can set up a distributed table and have one of your shards located somewhere completely else, in other region, in other data center, and use it just to send the data in there. Not a part of your primary cluster. In this case, you can use internal replication true, and that will send the data asynchronously to some other location. Kind of a way to use a backup or something similar.
Got it. Okay, great. Well, I think we're at time, and I don't see additional questions. I'd like to thank everybody for filling out the poll. Thank you so much. And I'm looking at these. These are great choices. Performance tuning looks like it's our winner today. We're going to, and we will, so that's definitely one that we'll consider. I know one I really like Arrays, so I'm glad to see that they're doing fairly well, but we will continue to do this webinar series. We do them about once a month. That's our goal, and we will, you'll see these topics come up. You'll also see more on replication. We'll redo this. We'll continue to repeat this over time. One final thing is we're presenting basic information. If you're have deeper questions about this, by all means, give us a call. We do, as you probably saw on the last slide, we do a free 1-hour consultation. Please do take us up on that. We're happy to look at your systems, give advice, and then if you need help either evaluating, deploying, or running systems, that's our business, and we'd be delighted to help you. So I'd like to thank Alexander and Valerie for helping make this a really great webinar. Thank you both. I couldn't have done it without you. And thanks to all of you who've attended, and we hope to see you again soon.